China has unveiled over 100 advanced radar systems at the 11th World Radar Expo, including a mobile meter-wave radar that Chinese media claims can detect American fifth-generation stealth fighters, such as the F-22 and F-35. Showcasing its advancements in anti-stealth radar systems, China presented the JY-27V radar system, manufactured by the state-owned China Electronics Technology Group Corp. (CETC), at the World Radio Detection and Ranging Expo in Hefei, East China's Anhui Province. The JY-27V, which is mounted on a military truck, is a high-mobility air surveillance radar. This next-generation meter-wave anti-stealth radar incorporates three advanced technologies: a low-frequency band, a high-power aperture, and sophisticated intelligent algorithms. According to the state-owned Global Times, these advanced technologies enable the radar system to precisely detect stealth targets and guide an air defense system for a precision strike. CETC described the JY-27V as a master artist in detecting stealth targets, highlighting its large array design and significant spread-retract ratio, which allows for rapid deployment and retraction within 10 minutes. CETC scientist Xu Haizhou was quoted by the state-owned Xinhua news agency as saying the antenna's automatic folding and unfolding was smooth and quiet. The system features a massive panel of active electronically scanned array (AESA) antennas, which work with very high frequency (VHF) radio waves. The radar is an upgrade of the JY-27A, which was unveiled at the 2016 Zhuhai Air Show together with the YLC-8B, an ultra-high-frequency UHF radar also designed for anti-stealth surveillance. According to CETC, compared to the JY-27A, the JY-27V features a bigger antenna, lower frequency, larger power aperture, and refined intelligence algorithms, which increase its ability to detect stealth targets. The larger the antenna diameter, the farther the range of detection is, Xu told the media at the expo. Notably, even in 2016, China claimed that its JY-27A radar can detect stealth targets like the F-22 Raptor, perhaps the world's most advanced fifth-generation stealth aircraft. At that time, it was reported that China might have used the JY-27A or YLC-8B, or both together, to detect the stealth fighters from more than 250 kilometers (155 miles) away. The VHF radar uses radio waves typically with frequencies ranging from 30 to 300 MHz, corresponding to wavelengths of 1 to 10 meters, 3.3 to 33 feet. In contrast, the UHF radar operates with frequencies between 300 to 3000 MHz, resulting in wavelengths of 0.1 to 1 meter. Radars work by sending out beams of radio waves. When these radio waves are reflected back by an aircraft or missile, the radar is alerted, and it can compute the distance and speed of the intruding projectile. The purpose of a stealth aircraft is to make the jet invisible to radar by reducing its radar cross-section, RCS. This is achieved in two ways. Firstly, the aircraft can be shaped in such a way that it reflects radar signals away from the radar source. Secondly, the aircraft could be cloaked with radar-absorbing materials, RAM, that absorb radar signals instead of reflecting them. However, these technologies are most effective against shorter wavelengths commonly used by conventional radars. The effectiveness of RAM is directly related to the wavelength of the radar waves. For a radar wave to be effectively absorbed, the thickness of the RAM must be proportional to the wavelength. This means that meter-wave radar, with its longer wavelengths, requires thicker and more complex RAM to be effectively shielded. Most modern stealth aircraft, such as the F-22 Raptor and the F-35 Lightning II, are primarily designed to evade detection by microwave radars. The radar-absorbing coating on these aircraft can only reduce echo on wavelengths of 0.01 to 0.1 meters. However, meter-wave radars, like the JY-27V, with their longer wavelengths, can still detect stealth aircraft. While the JY-27V was the highlight of the expo, CETC also showcased other radars at the event, which concluded on May 20th. CETC unveiled another anti-stealth radar, the YLC-8E, an upgrade of the YLC-8B. It is a 3-coordinate air surveillance radar that works on the UHF band. The Global Times reported that the YLC-8E provides long-range early warning and detection of stealth aircraft through a fully digital phased array system featuring 2D phased scanning and directional mechanical scanning, large phased array antennas, and high-power, high-efficiency digital TR units. The system offers several advantages, including enhanced anti-stealth capabilities, improved mobility, enhanced anti-jamming performance, increased reliability, and ease of maintenance. CETC also showcased the SLC-7 radar, a fourth-generation intelligence radar that can detect, track, and engage multiple targets. Its strengths include a long detection range, high data rate, adaptive anti-jamming capabilities, fast target identification, high reliability, and the ability to simultaneously search for, identify, lock onto, and track multiple targets. CETC said that the SLC-7 radar also features a high degree of accuracy. Besides, CETC also showcased JY-11S Band 3 Face Array Low-Altitude Surveillance Radar, described as a world-class counter-drone product. The YLC-12C Band Low to Medium Altitude Multirole Radar, designed to detect low-flying, slow-moving, and highly maneuverable targets, was also presented at the event, the China Daily reported. The JYL-1 long-range three-dimensional surveillance radar, engineered for unattended operation and suited for deployment in challenging environments such as plateaus, deserts, and islands, was also unveiled. Together, these radar systems underscored CETC's leadership in radar design and manufacturing.